Hello everyone. Uh, let's start with this particular series, AAHL paper 2 of November 22. And in this is the first question. Here two vectors have been given and we need to solve two questions under this. And each carries 3 marks. Let's get into this. U vector is I plus j and V vector is cos 1 by ni plus 1 by sin 1 by nj. So find cos theta in terms of n. Right? Okay, so here we are going to directly use the formula cos theta like angle between two vectors and theta is the angle between u and v. So the main angle between the two vectors formula is cos theta equal to some expression and it is given over in the formula booklet. You can refer here. Let me share that part. Here. So this is the part we can see. Angle between two vectors is cos theta into v1 w1, v2 w2, v2 w3. It's nothing but a scalar product and divided by mod v times mod w. But in our problem, it's u and v and it's a two-dimensional vector, not a three-dimensional one. So we have to just make the formula for the subject of two vectors, not for three. And let's get back to the solution part now. Okay, so that's the formula. You can refer and do that. And for this, only it's a 2D vector, right? No third dimension here. So let's start. Right. So the formula is going to be cos theta is equal to, like this is the component u1, u2, and this is the component v1, v2. So how will you do the scalar product? u1 with v1 and u2 with v2, like I component with I component, j component with j component. That's the sense. So let's make the formula for this. u1 v1 plus u2 v2 and divided by modulus u times modulus v. That's it. Now we need to solve for it. So first u1 times v1. So u1 is 1, v1 is, so this is cos 1 by n plus u2 v2 like 1 into sin 1 by n, which is sin 1 by n. And how to find the modulus? So that particular thing, modulus is a general, it is in 3.12. Let me show it for you again. Here. So modulus of a vector is square root of their square root of the sum of the squares of their component. Right? Very simple. Let's get back to the solution. So here modulus of u is going to be square root of 1 square plus 1 square because u1 is also 1 and u2 is also 1. Right? Then modulus of v. Okay. Let it be divided by modulus u times modulus v and let's solve this. Modulus v is first component cos square 1 by n plus sine square 1 by n. And cos square theta plus sine square theta, we know it's 1. This also we can find it in the trigonometric section. Let me show that particular formula for you. So cos square theta plus sine square theta is equal to 1. This is a very basic formula and also it is in the booklet. So cos square 1 by n plus sine square n by n, it is going to be 1 only. Right? Let's get back to this. So this is going to be 1. right? So mod b is 1. Square root of 1, which is just 1. And following this over here, which is cos 1 by n plus sine 1 by n. And what about this u? It is root 2, right? Divided by root 2 times 1. And it is just 1 by root 2 times cos 1 by n plus sine 1 by n. So we have expressed cos theta in terms of n. This is that expression. 1 by root 2 cos 1n plus sine 1 over n. This completes the solution. Easy 3 mark. Whatever the formula you're looking for is available over there in the formula sheet. Right? And let's get into the next part. Exact value of limit approached by theta as n tends to infinity. Right? So it is very simple. Like the limit concept, trigonometric limits. And let's get into that. First, I want to find limit approached by theta as n tend to infinity. So let's make an expression for theta. Already we have solved in the first question. Cos theta is equal to, what is that? 1 by root 2 cos 1 over n plus sine 1 over n, right? So what is theta? From this, it's quite simple. Cos inverse of, let me make a square bracket, and it is cos 1 over n plus sine 1 over n divided by root 2. So this is an expression. Now, for this theta, limit n tend to infinity, we need to do that on both sides. So limit n tend to infinity, theta. Here, limit n tend to infinity, cos inverse of cos 1 over n plus sine 1 over n divided by root 2. This root 2, okay. Now, okay, when you substitute like n is equal to infinity in this place, infinity is just a concept, it's a very big number. So 1 by a very, very big number, it's 1 by that big number, it will approach the 0, right? Also, we know this as a concept. 1 by n tends to 0 when n approaches infinity, positive infinity. And particularly, we are solving this for n belongs to z plus. So no need to worry, okay, what if it's minus infinity? So strictly n belongs to z plus, right? Positive and integers, right? So now 1 by n tends to 0, I know. What about cos 1 by n? So I want to convert into a particular value, right? So limit n tend to infinity. Okay, cos n, let's go with this. So when 1 by n tends to 0, cos 1 by n tends to cos 0. So this is nothing but cos 0 is what? It is just 1. Right? This we're going to substitute. And okay, same time. So in the same expression, what will sine 1 by n will converge to? So it will approach. So sine 1 by n will approach sine 0 and sine 0 is 0. That's it. We can replace these values in this expression and we will get limit n tend to infinity is applied. So cos inverse, after applying those limits, I got 1 and 0. So 1 plus 0 divided by root 2, which is cos inverse 1 over root 2. They're looking for the exact values. So we should memorize this value. This is not given in the formula booklet. So cos inverse 1 by root 2 is pi by 4. So pi by 4 is the answer. It is mentioned that we need to give exact values here. So exactly we have to give 0.78 something. If we solve in calculator, we'll get that is not accepted. So that's simple. This particular question, totally 6 and a very basic concept over here. With the calculator and with the formula booklet, it can be solved easily and quickly, right? And thank you so much for listening. Let's meet in the next video.